Good afternoon, all. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. So today we are going to start with the PCNF. So last lecture we had seen what is PDNF, that is principal disjunctive normal form or sum of product canonical form. So here in this lecture we are going to see what is PCNF. So PCNF starts for uh, principal conjunctive normal form, and this is also called as product of some canonical form. So what is the definition for this? Every Boolean expression in n variables is equivalent to a Boolean expression consisting of product of max terms only. So such a canonical form is known as product of some canonical form. So in short, we can say that any Boolean expression which is consist of product of max terms. So this is called as PCNF. So keep in mind that minterm is associated with PDNF and maxterm is associated with PCNF. So can anybody tell me how we can write the minterm? What is this symbol used to connect the symbols or connect the variables in minterm? Just give me one example of minterm. Suppose there are two variables x1 and x2 and we want to define minterm out of these two variables. So first question
X1 star X2.
is correct. X1 star x2. So how many possible minterms are there?
4.
4.
Four.
And those are, first we can define as x1 star x2, second one x1 complement star x2, third one x1 star x2 complement, and last one x1 complement star x2 complement. So likewise we can define the minterm. So similarly here we can define maxterm. So for that we have to use symbol XOR. So like in the minterm, we have used symbol for connecting the variables as a star. So here we have to use that symbol as XOR. So these are called as max terms. Okay. So have you understood what is meaning of PCNF?
Yes, ma'am.
Okay. So now here we have to solve some examples based on PCNF. So we have seen PCNF means what? Product of maxterm, okay, or product of some canonical form. So here question is given as obtain the product of some canonical form of the Boolean expression. So first expression is given as x1 star x2. Okay. So here we have to think about this given expression. We want this expression into form of product of sum. So here product is there is. So we can consider x1 and x2. These are two separate variables, and for these two variables we have to define some product of some canonical form. So this product is there. So for this x1 we have to think about which variable is missing. So for this x1 x2 is missing. So we have to add it by ourselves, and for this x2 x1 is missing. So first of all, we have to recognize missing variables. So how we can write here x1 XOR x2 star x2 complement. So this is the new term we have added in order to complete this whole bracket. Last lecture also we have seen each and every bracket of that final answer must contain mentioned variables. So here they have mentioned there are two variables x1 and x2. So every bracket of your answer must contain both the variables. So for that purpose we have added here new term as x2 star x2 complement. So keep in mind for this PCNF outside the bracket you have to take this XOR, or we can say OR symbol, and inside the bracket there is star symbol. So in the case of PDNF, it was how we were adding the new symbols, missing variables. कोणी सांगेल काय? टर्म कशी आपण ऍड करत होतो? Which symbol we have taken outside the bracket? Which one?
Or
Star symbol.
Yes, star symbol, or we can say and symbol. Okay. So here for this PDNF, we have to, while adding the new symbol or missing variable, we have to take and outside the bracket and or inside the bracket. And for this PCNF, we have to take or outside the bracket and inside the bracket. So these things are very important. Otherwise, you will get wrong answer. Okay. So for this PCNF, we have to take this OR symbol outside the bracket and symbol inside the bracket while adding missing term. Okay. So now apply the distributive law here. X1 XOR X2 star X1 XOR X2 complement. So here we have applied distributive law for this first bracket. So have we understood how we have applied it? समजलं का distributive law?
Yes, ma'am.
Okay. Now star operation, second variable is X2, and for this X2 missing is X1. So now we have to add it. So how we have added? X2 XOR X1 star X1 complement. Again, effect of this bracket is null over X2. Why? Because value of this term X1 star X1 complement. So this is just like 1 into 0. So answer for this one is 0. So again X2 XOR 0. This was addition of X2 and 0. So it will give you X2 only. That's why this bracket will not affect this original variable X2. So we can add it. So again we have to apply here distributive law like X2 XOR X1. But what is our rule? Your variables should be in the correct sequence like X1, X2, X3 likewise. So here we have taken X1 XOR X2. Now star operation and remaining one is X1 complement XOR X2. Just we have applied distributive law. Okay. So now check whether there is any term which is repeated here. Is X1 XOR X2, that is here and here also. So we can consider that term once. So it is X1 XOR X2. This is first bracket. Second one X1 XOR X2's complement star. Third one X1 complement XOR X2. Okay. Now check whether this one is in product of sum form. Check here. Product is here. Yes, that is correct. And sum is here. So this is a correct format. Now check whether each and every bracket is containing both the variables X1 X2 X1 X2 X1 X2. Yes, that's why whatever answer we got, that is correct. Okay. Have we understood?
Yes, ma'am.
Okay. Now you have to solve this same example using truth table. So like just we had seen in PDNF. So for PDNF, we were considering value as 1. If your last column is containing 1, then only we are considering value for those mentioned variables. So likewise here we have to consider value in the last column as 0. जर तुमच्या लास्ट कॉलम मध्ये 0 असेल तरच आपण रिस्पेक्टिव्ह x1 आणि x2 ची व्हॅल्यू चेक करणार आहे. and from that we have to define max terms, and then we have to find product of some canonical form. So can you solve this example using truth table? Okay, just wait. I will tell you how to solve this kind of example. Okay. So here question is given as find product of some canonical form of following Boolean expressions using truth table and algebraic method. Okay. So first equation or first function is given as f of x, y, z. This is equals to x and y's complement. Okay. So this and is similar to star. So we can use either star or this and symbol. And this function is consist of three variables x, y, z. So first we are going to solve this by using truth table. So check here. These symbols are x, y, z. Then next one is y's complement, and last one x and y's complement. So first we will find truth table. So for this first x, 4 ones are there, 4 zeros are there. Then for y, 2 ones, 2 zeros. Likewise, then for z, 1 0, 1 0. Now, y's complement means what? Again, 1 should be replaced by 0 and 0 should be replaced by 1. So, this 1 1, it becomes 0 0, 0 0 becomes 1 1. So, again we have to repeat it. And next one is x and y's complement. So, we have to take product between this column and this column, that is x and y's complement. So value in the final column will be 1 if value of x is 1 and y's complement is 1. So check here, first row 1 0, that's why final value is 0. Again 1 0, so again it is 0. Then 1 1, yes. So here both the values are 1, that's why value in the final column will be 1. Now check again, this value is 1, here it is 1. So again 1 1, it is 1. 0 0 0 0 0 0 0 1 0 and 0 1 0. Okay. So now in the case of PCNF, we have to check for where we have written 0 in the last column. So check here, 1, 2, 3, 4, 5, 6. 6 zeros are there, and for all these zeros, we have to check for respective value of x, y, and z. Okay. So check here, first 0 is written in the first row and value of x, y, z is 1, 1, 1. Now we have to mention that variable is in its original form if value of that variable is 0, and we have to give complement if value of that variable is 1. This is exactly opposite to PDNF. आपण PDNF मध्ये काय करायचं, लास्ट कॉलम मध्ये कुठे 1 आहे ते चेक करायचं आणि त्या 1 साठी रिस्पेक्टिव्ह एक्स वाय झेड ची व्हॅल्यू काय आहे हे चेक करायचं. अगेन इफ व्हॅल्यू ऑफ दोज व्हेरिएबल So we were discussing this example for PCNF. So what we have seen in the case of PCNF, we have to check where we have written 0 in the last column. Okay. So see here, zeros are written here 1, 2, 3, 4, 5, 6 times. So for first 0, what are the values of x, y and z? If value of that variable is 1, then we have to take its complement. And if value of that variable is 0, then we have to write that variable is in its original form. म्हणजे काय जर 1 असेल तर त्याची कॉम्प्लिमेंट घ्यायची आहे 0 असेल तर आहे तोच व्हेरिएबल लिहायचे ओके सो लाइकवाइज वी विल कंटिन्यू टू फाइंड max terms in this form. So for this 0, what is the max term? x1 complement xor y complement xor z. Okay. Check here. For this 0, x complement xor y complement xor z complement. So why we have written here complement for these three variables x, y, z? Because value of these three variables is 1. 1 असेल तर आपण काय करणार आहे त्याची कॉम्प्लिमेंट घ्यायची आणि 0 असेल तर तो व्हेरिएबल ओरिजिनल फॉर्म मध्ये कन्सिडर करायचा दॅट्स व्हाय फर्स्ट मॅक्स टर्म बिकम्स x complement xor y's complement xor z complement. So up till now, have you understood how we get first max term?
Yes, ma'am.
Okay. Now check second 0 we got in the second row. Now for this 0, what are the values of x, y and z? It is 1, 1, 0. So can anybody tell me what is the respective max term here?
X1 complement XOR Y complement XOR Z.
Yes, correct. X complement XOR Y's complement XOR Z. Because here sequence is 1, 1, 0. So for these first two ones, we have to take complement of those two variables, and for this 0, we have to write that variable in original form. Correct. Now for this next 0, what is the max term? This sequence is 0, 1, 1. So what is the max term?
X complement.
X XOR Y's complement XOR Z complement. Now next 0, sequence is 0, 1, 0. So its max term is
X XOR Y or Z.
no, your voice is not audible. Can you repeat?
X XOR Y complement XOR Z.
Yes, correct. X XOR Y's complement XOR Z. Now next 0, its sequence is 0, 0, 1. So max term is
X XOR Y XOR Z complement.
is x XOR y XOR z's complement. And for this last 0, values are 0, 0, 0.
X complement Y X XOR X XOR Y XOR Z.
Yes, here all values are 0. So we have to consider those variables in original form as x XOR y XOR z. Okay. Now we got all these max terms. So now we can form product of sum canonical form. So just we have to write and in between these max terms. Here, that is and is written here. So all these max terms are connected, and this is in form of product of sum, because outside the bracket product is there and inside the bracket or is there. So product of sum. So likewise you have to find for this example. We have seen this example for product of sum canonical form, but this is by algebraic method. Now you have to solve this same example using truth table method. So is it possible to solve this example? Can you solve it? Same procedure you have to apply. Okay. So take time of 5 minutes, solve it on page and mention or send me your answer on our WhatsApp group. Just take 5 minutes. Because just two variables are here, x1 and x2. So it will not take much time. Again, you can use either star operation or AND operation or XOR operation or OR operation. So out of these symbols, you can use any two symbols. Okay, so first of all, just tell me what would be the possible columns in truth table.
x1, x2, and x1 star x2.
Yes, correct. So solve this example and tell me what is your answer. So I got a reply from Madhuri, and that is correct answer. So I have posted that answer on your WhatsApp group. So columns are x1, x2, and last column is x1 star x2. Okay. So values of x1 and x2 for x1 0 0 1 1, for x2 0 1 0 1. Okay. Now check for this product operation x1 and x2. We have to write 1 if values of x1 and x2 are 1. Otherwise, it is 0. So check here. In the last row, value of x1 and x2 are 1, 1. That's why final value is 1. and for rest of part we have to write 0. So now in the last column we got values as 0, 0, 0, 1. So now we have to check where we have written 0 in the last column. So first 0, value of x1 and x2 for it are 0, 0. So we have to consider those two variables in original form. So respective max term is x1, xor, x2. Okay. Now next 0, values of x1 and x2 are 0, 1. So max term becomes x1, xor, x2's complement. Now for this third 0, values of x1 and x2 are 1 and 0. So for this one, we have to take its complement as x1 complement xor x2. So we got three max terms. Now we have to write it in form of product of sum. So just we have to connect all these three max terms by star operation. So this is required product of sum canonical form, or we can say PCNF for this given expression. Now compare whatever result we got by truth table and by algebraic method, whether it is same. Yes, both the answers are same. So we can say that this answer is correct. So have you understood this first example?
Yes, ma'am.
Okay. No. Now you have to consider if this is consist of three variables. आता आपण solve कशासाठी केला? If your example is consist of just two variables. Now consider if it is consist of three variables. काय करावं लागेल मग? Just you have to add now variable x3 in each and every bracket. Now check here. It is consist of x1, x2, x1, x2, x1, x2. Now if your Boolean expression is consist of three variables x1, x2, x3, then what we have to add? We have to add x3 in each and every variable, every term. So consider first one. Here we have written x1, xor, x2. So now in this case, missing variable will be x3. So we have to add it. So how we can add x1, xor, x2, xor in bracket x3 star x3 complement. So likewise, we can add missing term x3 if our expression is consist of three variables. आता आपण जे सॉल्व केलं ते कशासाठी होता? जर आपल्या एक्सप्रेशन मध्ये दोनच व्हेरिएबल्स असतील तर this answer is correct. Now you have to consider if our expression is consist of three variables. So first of all, try to solve this one by using truth table. Then I will tell you how to solve it for algebraic method. Can you solve it using truth table? If your expression is consist of three variables.
Yes, ma'am.
Okay. So consider it. It is consist of three variables and find value for x1 star x2. That is product of sum canonical form. Take 5 minutes and solve it. Then we will see how to solve it by algebraic method. Hello. So correct answer for this one I have posted on your group. That is again solved by Madhuri, and that is correct. So check here. In the last column, we got total 6 zeros, and or for all these zeros, we have to find respective max term. So consider here first 0 and values of x1, x2, x3 are 1, 0, 1. So for this sequence, what is the max term? x1 complement, xor, x2, xor, x3 complement. Now for this second 0, values of x1, x2, x3 are 1, 0, 0. So again, its max term becomes x1 complement, xor, x2, xor, x3. Now for third 0, sequence is 0, 1, 1. So its max term becomes x1, xor, x2 complement, xor, x3 complement. And then next one is 0, 1, 0. So again its max term is x1, xor, x2 complement, xor, x3. Then next 0, values of these variables is 0, 0, 1. So again x1, xor, x2, xor, x3 complement. And for last zeros, value of these three variables, it is 0, 0, 0. In short, x1, xor, x2, xor, x3. Now we have to connect all these max terms by star operation. So this is a required product of sum canonical form. Have we understood how we have solved it?
Yes, ma'am.
Okay. So now we have to solve it by algebraic method if this is consist of three variables. Now up till now we have solved it by using two variables x1 and x2. Now we have to add one more variable, and that variable is x3. So first bracket is x1, xor, x2. Now for this bracket x3 is missing. And how we can add it? XOR in bracket x3 star x3 complement. So after applying distributive law, we will get x1 XOR x2 XOR x3 star x1 XOR x2 XOR x3 complement. I have written here directly. So likewise, for this second bracket, again we have to add x3 as a missing variable. So it becomes x1 XOR x2 complement. Now we have to add x3 as XOR in bracket x3 star x3 complement. So after applying distributive law, you will get x1 XOR x2 complement XOR x3, and after that star operation x1 XOR x2 complement XOR x3 complement. So likewise, we can add x3 for this last bracket as x1 complement XOR x2 XOR x3 star x3 complement. So again we have to apply distributive law, and after that we will get answer as x1 complement XOR x2 XOR x3 star x1 complement XOR x2 XOR x3 complement. So this is a required product of sum canonical form. So again we can transform this like in terms of max. So apply here, transform this one into Boolean form. So again we have to keep this rule in mind. If 1 is there, then we have to take complement, and if 0 is there, then we have to write that variable in original form. Or we can apply it in reverse order here. x1 XOR x2 XOR x3. So what is the equivalent Boolean conversion? Sorry, binary conversion. Binary form मध्ये आपण कसं लिहिणार आहे याला? जर व्हेरिएबल ओरिजिनल फॉर्म मध्ये असेल तर त्याची व्हॅल्यू आपण काय देतो? 0. सो अगेन 0, 0, 0. In short, it becomes 0. So first term is max of 0. Now second one, x1 XOR x2 XOR x3 complement. So what is required binary format? याचं बायनरी कन्वर्जन काय येईल? जर ओरिजिनल व्हेरिएबल असेल तर तुम्हाला 0 असाइन करायचं.
0, 0, 1.
Yes, 0, 0, 1. So this is equivalent to 1. So we have written here second term as max of 1. Now for this third term, again it is first value is x1. So it is in original format. So we have to assign value as 0. 0, 1, 0. And this is for max of 2. So likewise 0, sorry, is 0, 1, 1. So this is for max of 3. Next term 1, 0, 0. This is for max of 4. And again for this complement we have to write 1, 0, again 1. So 1, 0, 1. This sequence is for max of 5. So now we can write this one as star 0, 1, 2, 3, 4, 5. So this is the answer for product of some canonical form if your expression is consist of 3 variables. So have you understood this example?
Yes, ma'am.
Okay. Now for this second example, it is given as x1 XOR x2. Okay. So first we will solve it for algebraic method. So first of all check what is the given format here. आपल्याला काय पाहिजे प्रोडक्ट ऑफ सम. ओके आता सम घेतली तर x1 x2 आहे. मिसिंग व्हेरिएबल कोणता आहे यात x3. सो वी हॅव टू ऍड इट. सो हाऊ वी हॅव ऍडेड हियर x1 XOR x2. दिस इज गिवन टर्म and for this term one variable is missing, that is x3, that we have added like XOR in bracket x3 star x3 complement. So again we have to apply distributive law as x1 XOR x2 XOR x3. This is one bracket star operation x1 XOR x2 XOR x3 complement. So again we have to convert this one into Boolean form, binary form, as if original variable is there we have to assign value as 0. So first bracket becomes 0, 0, 0, that is max of 0, star operation, then 0, 0, 1, and 0, 0, 1 means what? It is 1. So max of 0 star max of 1. So again we can write this one as star 0, 1. So this is required product of sum form for this given expression by using algebraic method. Now same you have to try by truth table method. So solve this example for truth table method. I am getting reply from only one student. So what others are doing now? What is the thing? Are you getting this or not? हॅलो, समजते का तुम्हाला काय चाललंय ते? डोक्यावरून चाललंय. मग रिप्लाय फक्त एका स्टुडंट कडून काय येतं? जोपर्यंत तुम्ही स्वतः सॉल्व्ह करत नाही तोपर्यंत तुम्हाला हे टर्म समजणार नाही. त्यासाठी मी तुम्हाला सॉल्व्ह करायला सांगते. So everyone must try. So check this answer. Here variables are x1, x2 and x3. So 3 columns are there and we have to find value for x1, xor, x2. So again, here value of x1, xor, x2, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1. And for last two rows, 0, 0, it is 0. Now, in the final column, we are interested to know where we have written value as 0. So for last two rows, we have written 0. So for that first 0, values of x1, x2 and x3 are 0, 0, 1. So again, if value of that variable is 0, we saw that is a original form. And if value of that variable is 1, then it is in complementary form. So for this sequence 0, 0, 1, max term becomes x1, xor, x2, xor, x3 complement. And for next 0, value of x1, x2, x3, it is 0, 0, 0. Means what? All the variables are in original form. That is x1, xor, x2, xor, x3. And again, we have to take product of sum form. That's why we have to take product of these two max terms. So it will give you required format. Now compare these two results. Whatever result we got from algebraic method and whatever result we get here from truth table. And these two results are same. So whatever answer we have find out, that is correct. Okay. So now you have to solve some examples based on this PCNF again. So first example we have seen for truth table. Truth table साठीच example आपण बघितलं. For these three variables x, y, z. Now we have to solve this for algebraic method. So here that solution is given. Given function f is equals to x and y's complement. Okay. Now we want this in form of product of sum. Okay. So product is written here. So we can treat now x and y's complement. These are two separate terms. And for these terms, we have to add missing variable. So first of all, we have to check our function is consists of three variables x, y, and z. Means what? Your answer must contain x, y, z variables for each and every bracket. Now, for this x, two variables are missing and those variables are y and z. And for this y, again two variables are missing. Those are x and z. So one by one we will add these missing variables. So first of all, consider this term as x. So for this x, first we are going to add this missing term as y, and then afterwards we will add z. Okay. So how we can add this missing term? X or y and y's complement. So otherwise we can write this one as x XOR y star y's complement. Meaning of this both the terms is same. You can use either of combination. So here x or y, this is one bracket, and x or y's complement, this is another bracket after applying distributive law. Okay, and this symbol is written here, and now y's complement. So for this y's complement, again two variables are missing, x and z. So out of these two variables, I have added here first variable as x. So y's complement or x and x complement. So again we have to apply here distributive law. So how we can apply x or y's complement? You can write y's complement or x, but afterwards again you have to write this one as x or y's complement only. Why? Because this sequence must be same as given in function. आता फंक्शन मध्ये सिक्वेन्स काय दिलाय एक्स वाय झेड, तसाच सिक्वेन्स आपल्याला प्रत्येक ब्रॅकेट मध्ये पाहिजे. सो वी हॅव रिटन दिस वन एज एक्स और वाय's complement and x complement or y's complement. This is next bracket. So have you understood this example up to this step?
Yes, ma'am.
Okay. Now, yes. Hello.
Can you repeat?
Yes. Check
Can-
here. This given function.
Hello, ma'am. Can you repeat?
Yes, yes. Yes, I will repeat. Check here. Given function is x and y's complement. Okay. And we want this one into product of some form. Product म्हणजे काय? And operation आहे. And sum म्हणजे काय? XOR operation. So and operation is given here between these two variables x and y's complement. म्हणजे काय? x ही टर्म सेपरेट आहे, y's complement ही टर्म सेपरेट आहे. त्यांच्यामध्ये प्रोडक्ट आहे. आता ह्या दोन्ही टर्म साठी आपल्याला मिसिंग व्हेरिएबल कुठले आहेत ते चेक करायचे. So our function is consist of three variables x, y, z. तीन व्हेरिएबल आहेत. Okay. So out of these three variables, our first term is consist of just one variable, that is x. So for this x, two variables are missing, y and z. So we have to add these both terms or both variables, but we can add only one variable at a time. Y आणि z हे दोन्ही जरी मिसिंग असतील तरी आपण at a time दोन्ही व्हेरिएबल ऍड करू शकत नाही. So for that purpose, we have to consider only one variable at a time. So here we have considered that variable as y. The y कसा add करणार आहे? X or y and y's complement. So this is the format to add missing variable in case of PCNF. हा सिक्वेन्स असंच ठेवायचं तुम्हाला, ब्रॅकेटच्या बाहेर ऑर लिहावं लागेल, ब्रॅकेट मध्ये अँड लिहावं लागेल. आणि कुठलं मिसिंग व्हेरिएबल आहे? y. So y and y's complement. Now apply distributive law. So x or y, this is first term, and x or y's complement, this is second term. Just we have applied distributive law. So up till now, have you understood?
Yes, ma'am.
Okay. Now next symbol is and, that is written over here, and next variable is y's complement. So for this y's complement, again two variables are missing, x and z, but at a time we can add only one variable. So we have considered here variable to be added as x. So how we have written y's complement or x and x complement. Now again we have to apply distributive law as x or y's complement and x complement or y's complement. So those terms we have written here. Now check, every bracket is containing two variables x and y. Now for each and every bracket, again one term is missing, and that term is z. So we have to add it by ourselves. So before that, just check whether there is any term repeated. So yes, here one term is repeated and that is x or y's complement. So we will consider this term as only once. So check here x or y. This is first term. Second term is x or y's complement, and third term is x complement or y complement. Now for this whole bracket, we have to add missing term and that term is z. So again, format for adding missing term is same. Outside of bracket, we should write or, and inside the bracket, we should write and. So z and z complement. Just a minute. Huh. Okay. So for this term, we have to add z. So again, we have to apply distributive law. So first bracket becomes x or y or z. Now second one, x or y or z complement. Next one, x or y's complement or z. Next one, x or y's complement or z complement. Again next, x complement or y's complement or z, and x complement or y's complement or z complement. So all these are the max terms, and now we have to connect all these max terms by and symbol. That is given here because each and every term is connected here by and symbol. So this is a required product of sum form. So just let me know, have you understood this example?
Yes, ma'am.
Okay. Now this second example you have to try. So first of all, solve this by truth table, and everyone you must try this. So function f is given as x, y, z. This is equals to x or y and x complement or z and y or z complement. So we have to find required product of some canonical form or PCNF, and it is consist of three variables. So first of all, solve this example by truth table. Then we will see what is by algebraic method. Is it fine?
Okay, ma'am.
Okay.
Yes, ma'am.
So solve it. Okay, so here for this example, it is consist of three variables x, y, z. So while finding value by using truth table, we have to consider all these columns as x, y, z, then x or y. Next one x complement, then x complement or z, z complement, y or z complement. Okay. So now we have to find its value by truth table. So value of x, y, z, you know. Now next column x or y. So for this column, if both are 0, then only final value is 0. Otherwise it is 1. So 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1. And for this last two rows, 0, 0, that is written here. Now next one is x complement. So x complement means what? Again, 1 should be replaced by 0 and 0 should be replaced by 1. So first 4 are zeros and next 4 are 1. Then x complement or z. So again 1 0 1 0 0 0 1 0 1 0 0 0 1 1 1 0 1 1, then 1 1 1 and 0 1 1. Now next column is z complement. So again same rule, 1 should be replaced by 0 and 0 should be replaced by 1. So this sequence is 0 1 0 1 likewise. And then y or z complement. So again, if both are 0, then only we have to write final value as 0. Now 1 0 1 1 1 1 0 0 0 0 1 1 1 0 1 1 1 1 0 0 0 and 0 1 1. Now final value of f. So for this we have to consider three columns: x or y, x complement or y, and y or z complement. So take AND operation between these three columns. So if all the values are 1, then only final value will be 1 because this is a product operation. So 1 1 1 final value is 1. 1 0 1 0 1 1 0 0 1 0 1 again it is 0, then 1 1 1 final value is 1, 1 1 1 again it is 1, then 0 1 0 it is 0, 0 1 1 so again it is 0. Now we have to observe last last column where we have written zeros. So 1, 2, 3, 4, 5. 5 zeros are there, and from these zeros we have to define max terms. So for this 0, what is the max term? This sequence of x, y, z is 1, 1, 0. In short, again, if 1 is there, we have to take its complement, and 0 is there, then we have to write original variable. So for this sequence, its max term is x complement or y's complement or z. Now for this second 0 sequence is 1, 0, 1. So again, x complement or y or z complement. So that term is written here. Now for this next 0, value of x, y, z 1, 0, 0. Means what? X complement or y or z. Now for this next one, 0, 0, 1. So again, x or y or z complement. And for this last 0, values of x, y, z are 0, 0, 0. So x or y or z. So this is the last value. So again, this is product of sum. So we have to connect all these max terms by AND operation. So again, this is product of sum. Inside the bracket OR is there, outside the bracket AND is there. So this is required product of sum canonical form or PCNF form for this given expression. Have you understood this example?
Yes, ma'am.
Okay. Now, same example you have to try for algebraic method. Okay, so take this one as homework. You have to find value for this expression, that is product of sum form, but by using algebraic method. Okay. So today we will stop here. Remaining examples we will see next lecture. Just give me present T. Okay, before that, note this example because you have to solve this example. Present T, roll number 1.
Yes,
2,
ma'am. Yes, ma'am.
3,
Yes, ma'am.
4,
Yes, ma'am.
5, Roll number 5. Roll number 6. 7. 8. Roll number 7. 8. 9.
Yes, ma'am.
10.
Present, ma'am.
11.
Yes, ma'am.
12.
Yes, ma'am.
13.
Yes, ma'am.
14.
Yes, ma'am.
15.
Present.
16.
Yes, ma'am.
17.
Yes, ma'am.
18.
Present, ma'am.
19.
Present, ma'am.
20. 21. 22.
Present, ma'am.
23.
Present, ma'am.
24.
Yes, ma'am.
25.
Yes, ma'am.
26.
Present, ma'am.
27. 28. 29.
Yes, ma'am.
30. 31.
Yes, ma'am.
32.
Present, ma'am.
33.
Present, ma'am.
34. 35. 36. 37. 38.
Present, ma'am.
39.
Yes, ma'am.
40.
Present, ma'am.
41. 42.
Yes, ma'am.
43. 44.
Present, ma'am.
45.
Yes, ma'am.
46.
Yes, ma'am.
47. 48. 49.
Yes, ma'am.
50. 51.
Present, ma'am.
52. 53. 54. present. Okay. 55, 56, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60, present. Okay. 61, 62, 63,
Present, ma'am.
64,
Yes, ma'am.
65, 66, 64 is present. Okay.
And 66 is present.
Okay. 67,
Present, ma'am.
68, 69, 70, 70. Okay, so check for absent numbers. Roll number 5, 6, 7, 8, 20, 21, 27, 28, 34, 35, 37, 41, 43, 47, 48, 50, 52, 53, 55, 56, 59, 61, 62, 68, 69, and 70.
Ma'am, 37.
37. Okay.
Ma'am, 8.
Roll number 8. Okay. Or okay. Thank you. We will stop here.